Hi guys, so we are going to be starting learning target 10, which is solving with similar triangles. Okay, so the focus of this one is going to be when you are given similar triangles, how can you use that information to find missing sides or missing angles. All right, so a couple things you want to remember here, that when you have similar triangles, your sides are all proportional. Okay, so remember that your sides are proportional. And then also, when you have similar triangles, all your corresponding angles are equal. Okay, so those are some of the things we're going to be using as we move through here. So this first example is what we call a nested triangle, because we have one triangle inside of another triangle. And the most common mistake with these triangles is that students don't listen when I tell them that the best and most effective way for this type of problem is to separate your triangles. Okay, you have one triangle inside of another triangle. It's not this part and this part. This down here, that's not a triangle. It's this part and this part. Okay, so when I say separate them, I mean you're literally going to draw those triangles over again, but separated. So this becomes 3 and 4. And then my bigger triangle is this whole side. So that's 3 plus 6.75, so that becomes 9.75. And then over here, it's this whole side. So 4 plus 9, which is 13. Okay, so now that I have my two separated triangles, I'm going to go through this kind of quickly because this is just to kind of give you an idea of how things match up. But AB over BC. Okay, so that's 4 over 9. AB over AC is AB, which is 4, over AC, which we said was 13. AE over ED is 3 over 6.75. And then AE over AD is 3 over 9.75. And that's just to show you the differences in how those ratios match up. Okay? All right. Down here, examples of how sides correspond. It would be B over F. Okay, so again, these are like parallel lines. Okay, and this is like your transversal. So these are congruent, these are congruent. This is congruent to this is congruent, which means this one has to be congruent to this one. And when I match up my corresponding sides, B is between the two-lined one and the one-lined one. So over here, between the two-lined one and the one-lined one, I have F. So it's B over F, C over D, and then A over E. Same thing over here. These are parallel. Okay, here's my transversal. I've got another one over there. So this one is congruent to this one. This one is congruent to this one. And then we have these two. So again, if I match up my corresponding sides, between one tick mark and two tick marks, I have A. Between one tick mark and two tick marks, I have Y. So I can do Y over A, X over B, and then Z over C. And that's just, again, to show you some examples of how your parts correspond. All right, so for this one, when I actually have to solve for a missing side, once again, I'm looking at this as, okay, these are kind of parallel. So that means this is congruent to this is congruent to this, those two, and hopefully now you've kind of seen this pattern of these are going to be the ones that correspond. So I have this ratio of 8 over 10. Well, say, for example, that I didn't look at the 8 over 10. Say, for example, I looked at the 12 and the 15. Okay, so 8 over 10 or 12 over 15. And just so you can tell, 8 divided by 10 is 0.8. 12 divided by 15, also 0.8. Okay, so it doesn't matter which of those two ratios I use. I only need one of them to then solve for my missing side. So let's say I go with the 8 over 10. Okay, I'm going to be setting up what's called a proportion. You guys have solved proportions before. Okay, so I have 8 over 10, and I'm going to be looking for this side that's x. So it means I need another side that corresponds to x, and that's going to be 11. If I went 8 over 10, then I have to do 11 over x. If I had done 10 over 8, then I could do x over 11. But because I did the 8 first, I have to do the 11 first. And then I'm going to cross multiply. So 8 times x is 8x. 10 times 11 is 110. And then I just have to solve for x. So I'm dividing by 8 on both sides. And you should finish this one off. Okay, so 13.75. Okay. Down here, we've got another example. Okay. Again, one triangle inside of another triangle, so that means you're going to separate them. This means in some cases right now that you're going to be drawing on your own. Okay, but it truly is the most effective way of doing these because it forces you to label those sides correctly. Okay, so right here, I've got 3. So you put that 3 here, and right here, I've got 12. Now in this case, this whole side is identified as x. So that's going to be this one over here, and then this bottom side is 4. And now I can go ahead and set up my proportion. So I match up corresponding sides. So I have 3 over 4 equals 12 over x. And that's what I'm going to cross multiply. Okay, so 3 times x is 3x. 4 times 12 is 48. And I'm going to divide by 3 on both sides. X equals 16. Now when it comes to angles, it's a little bit easier because remember that all your angles of a triangle have to add up to 180. So for example, in this first triangle, I have a 90-degree angle. That's what that box is. It's a right angle, which means it's 90 degrees. So I just have to do 180 minus 90 minus 33. Oops, that's 180 minus 90 minus 33, and minus the angle up here is 57. To find this one down here, I can already tell that my triangles are similar. I have 57 and 57, right angle, right angle. That's angle, angle. As soon as I know that my remaining angles are going to have to be the same. This one should come out to 33, but let's test this one as well. We're going to do 180 minus the 90 that we have there already, minus the 57 that's up at the top. And sure enough, it comes out to 33. Okay. One more example to go through here. Okay, let's just go through this one real quick. Okay, so for this one, we already have these angles labeled. We know these are vertical angles, so I'm going to label those. And again, now I can tell which sides correspond. 15 corresponds to x, and then 3 is going to correspond to 4. So I'm going to set up my proportion to show that. It doesn't matter if I do 15 over x or x over 15. Okay, if I do 15 over x, I have to do 3 over 4. If I do x over 15, I have to do 4 over 3. You have to keep the same triangle in the same position both ways, otherwise your problem's going to come out rough. And then I'm going to cross multiply. So 3 times x is 3x, 15 times 4 is 60, and then I'm going to divide by 3, x equals 20. You can see over here your numbers are going to work out the same way. 3 times x is 3x, 15 times 4 is 60. I get the same thing as I did over there. I could also do the 4 over 3 or the 3 over 4 first. As long as these pair up in the right order, you're going to be fine. Okay, so that is how we are solving for missing sides. It is all about setting up proportions. And then the tricky part, which is what we're going to practice the most, is just making sure that you are matching up the correct sides in the correct orders. Okay, and that's it.